Special triangles. All right, you're going to see two triangles here that might look a little familiar because we've talked about them before. So let's come over here. Oh, this mess. We did this before when we derived these special angles back in section chapter 1.2. So we derived these triangles here, and we have a 30, 60, 90 triangle is what this is called. And it's a 30-degree angle, 60-degree angle, 90-degree angle. And this one has a hypotenuse of 1. And when it had a hypotenuse of 1, the y, so this side opposite the 30-degree angle, was 1/2. And the x value, the value opposite the 60-degree angle, is square root 3 over 2. And we also derived, boom, 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 a 45, 45, 90 triangle where its side lengths were square root 2 over 2 and a hypotenuse of 1. So those are just cleared up right here. Now, this worksheet originally had a portion where I did a problem where the hypotenuse is 1. There might be one on your homework that looks like this. So I'm just going to kind of make up one up here. Let's see. Let's say this is the 60-degree angle. We'll say that that's a right angle. Just use your imagination. This is the 30-degree angle. And we want to know if the hypotenuse is 1, what these two side lengths are. So it's super easy to determine this. So in a 30, 60, 90 triangle, first of all, the largest angle is opposite the largest side. So the largest angle is the 90-degree angle. Hypotenuse is always the longest. The next biggest angle in this triangle is the 60-degree angle. And so this side over here, y, should be longer than x. And all we have to do is come back to this triangle and look at connecting angles. So the longest side, the side opposite the 60-degree angle, should be square root 3 over 2. So opposite the 60-degree angle, square root 3 over 2. And the other side, the one opposite the 30-degree angle, should be 1/2. All right, so you have a problem like that where the hypotenuse is 1. But I want to talk about some other cases here. So first, I want to remind everybody about the concept of similar triangles. So a similar triangle is going to be two triangles are similar if they have all the same angles and they have different side lengths. So let me actually do this in blue. Boom. Duplicate, style, pink. All right, I'm going to make this guy bigger. All right, so you saw me. I just copied that triangle, right? And all I did was make it bigger. You just saw me do it. Make this a little bit thicker there. All right, so this guy right here, all I did was make the triangle bigger. I kept the triangle the same. So that angle is the same. This angle is the same. And this angle is the same. So all the angles remain the same. It's just the size has grown. And what happens to the side lengths when we do something like this? Whoop, make you a little bit smaller. Boom. And make you a little bit smaller. What happens to the side lengths when we scale up two similar triangles, when we scale upwards or downwards? All you're doing is multiplying each side by the same number. So to get from here to here, let's say you multiplied by 2, you would multiply this side by 2 as well, and you would multiply this side by 2. That's how similar triangles work. If all the angles are the same, then the scaling of the sides is the same for all 3 sides. So looking here at this guy, we have a 30, 60, 90 triangle. This side right over here, that's unlabeled, should be 60 degrees. And that means it's scaled upward, right? We can look at our special 30, 60, 90 triangle. It's scaled upward from this. So in this case, the hypotenuse, which was 1 in our special triangle, is 16. So we're trying to figure out, make a little triangle here, what we need to multiply 1 by in order to get 16. I guess I should kind of like tilt this guy. Maybe I'll leave him like that. This is a 1/2. This is a √3 over 2. So what do we multiply 1 by to get 16? That's 16. We multiplied 1 by 16 and we got 16. So the side that's opposite the 30-degree angle, this one's the 30-degree angle, the side opposite the 30-degree angle, we should be multiplying that. So opposite the 30-degree angle, why don't we just highlight this? Opposite the 30, opposite the 30. So we want to be multiplying by 16 this way. So 1/2 times 16, x is equal to 1/2 times 16. So x is equal to 8. And then y this side here, the one opposite the 60-degree angle, so right down here, is going to be square root of 3 over 2 scaled upward by a factor of 16. So we take the square root of 3 divided by 2, multiply by 16, and we get that y is equal to 8 square root of 3. So what you're looking for here to scale upward, you're just multiplying each side by the same factor. And we know what the original factors are for a hypotenuse of 1 because we have a special triangle. Right, let's box these. Oh, that certainly was not a box. That's not going to be a box either. Box. Close enough. Next. 45, 45, 90 triangle. A regular 45, 45, 90 triangle, right up here. With 45, with a hypotenuse of 1, has side lengths that are the same. They're square root 2 over 2, square root 2 over 2. So let's start by identifying the hypotenuse. So the hypotenuse here, hypotenuse here. And then the legs, it doesn't matter which is which, they're the same length, right? So actually, this one could be here, this could be here, this could be here, this could be here, but they're the same length, which gives us one of them, like one of the answers right away, right? Same length as other leg, because legs are the same length in a 45, 45, 90 triangle. And this is because it's an isosceles triangle. All right. So x is equal to 10. Well, I'll put that down here in the corner. X is equal to 10. Done with that one. Now it's just y. So the question is, what do we need to multiply 1 by in order to get y? And we can't answer that question without knowing, we can't just have a 1 here and a y here and know what to do. But we know that the square root 2 over 2 has to scale upward to a 10. So what do we multiply? What do we multiply square root 2 over 2 by to get 10? So square root 2 over 2 times some constant that we're trying to solve for is equal to 10. What are we multiplying by square root 2 over 2 in order to get 10? We can get rid of the square root 2 over 2 in front of the c by multiplying both sides by square root 2 over by the reciprocal of square root 2 over 2, which is 2 over square root 2. Those cancel, these cancel. You're left with c is equal to 20 divided by the square root of 2. So the scaling factor here, the scaling factor is 20 over radical 2. You could rationalize if you want. I'm not going to bother. It's not a big deal to me. So we are multiplying 1 by 2 over the square root of, sorry, by 20 over the square root of 2. So y, I guess I should do that in pink, y is equal to 1 times 20 over square root 2, which is, of course, just 20 over square root 2. So y is equal to 20 divided by the square root of 2. And there's that one. You don't want to take a moment right now to pause this video and try out this problem on your own. So I'll give you a moment to pause before I start going through the answer. That was your moment. Okay. Now you're in it for the rest of it. Okay. So I'm going to go back to my 30, 60, 90 triangle here. 60 degrees. Right. So the hypotenuse, let's go ahead and label them. The hypotenuse, because it's opposite the right angle. Hypotenuse. The side opposite the 60-degree angle is going to be this pink one over here. So we'll highlight that one in pink. It helps to just match them up first. And the remaining one, of course, is then green, the side opposite the 30-degree angle. It helps because look at the orientation of these. It would be really easy to get these mistaken for which sides correspond to one another, just because they're flipped funny here. All right, so we want to know how much we scale up each of these sides to get to this triangle over here. And we're going to start with using these pink sides. We're asking ourselves the question, what do we multiply? So we take square root 3 over 2 and we multiply by some number that we're looking for to figure out what the scaling factor is. And then we'll get, so we had square root 3 over 2 on the pink side here, 12 over here. We're taking the side we know the most about and using it to find more information about the triangle. All right, so there we have square root 3 over 2 times something we're looking for is equal to 12. What is that scaling factor? What do I multiply by to get there? I am going to multiply both sides by 2 over radical 3 because that'll cancel out on the other side. Boom, 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 boom. We get c equal to 24 over radical 3. This would simplify if I rationalized it, but I just don't care to. All right. So boom, boom, boom. That's what we scale by. That's the factor we're scaling by, 24 over radical 3. We multiply the side length in our sample triangle, square root 3 over 2 by 24 over radical 3, and we should get 12. So we'll do that with all the side lengths. For the green one, multiply by 20, it's going to be 1/2 multiplied by 24 over radical 3, which is going to be 12 divided by radical 3. So x is equal to 12 divided by radical 3. And then from 1 to y, we're taking 1 and multiplying by 24 over radical 3. And that is, of course, 12 over or 24 over radical 3. 24 over radical 3. So y is equal to 24 over radical 3. And that's that. So it's just kind of paying close attention to what you're doing and knowing those special triangles. All right, well, that's all I have for this one, and I will see you in another video. Bye.